Alrighty, folks, in this video, we're going to go over the definition of what's called a derivative. Okay, so to kind of get us into eventually the definition of a derivative, let's first of all look at this picture that we've talked about in a previous video. So what I have here is a picture of what a secant line is, right? So we have a green graph. In this case, is parabolic. It's f. Let's call it f of x. If you recall, we said a secant line is a line that intersects your graph at exactly 2 points, right? And those 2 points here on the graph are indicated with the red points. And what we're saying here is that we have 2 points, and we gave them 2 different order pairs, right? We gave the left point x being the x coordinate, f of x being the y value, and then the second order pair would be x plus h as the x coordinate, f of x plus h being the y coordinate. And if you remember, we said h, or maybe we used delta x in the previous video, but remember we said h or delta x, or whatever you want to call it, is the distance between the two x coordinates. That's what we saw here, right? Okay, and then what we went on and figured out is we said that, hey, if we want to find what's called the average rate of change, remember we said that's the same thing as the slope of the secant line. And so what we did was we said, okay, all we have to do is take f of x plus h minus f of x and divide it by x plus h minus x, right? And then simplify that, and we end up with the slope of the secant line, which is the average rate of change, which was what I'm highlighting here. Okay, so the average rate of change can be found in exactly that way. Well, what is a derivative? Well, instead of knowing an average rate of change, so that's in business, it's like, how do my profits, how do my revenues change over time? Well, sometimes I don't want to know that. Sometimes instead I want to know, how are my profits changing at this particular instant in time? So instead of looking at a secant line, okay, to find what's called an instantaneous rate of change, what we need to look at instead is what's called a tangent line. Let me see if I could draw that here with a different color. Okay, so a tangent line. So what I want to do is I want to know, hey, what is the rate of change right there at just that point to the far left there? Okay, so that line that I just drew in cyan, in that light blue color there, that's what we call a tangent line. So a secant line intersects your graph at 2 places, where a tangent line only intersects your graph at 1 place. And so if I want to find this thing called an instantaneous rate of change, it's going to give me the point, it's going to give me the rate of change at exactly that left order pair there. All I have to do is find the slope of the tangent line. So let's write down that definition. So an instantaneous, I'm just call it instant for short. An instant rate of change is the slope of the secant line. Okay, is the slope of the secant line. Well, how do we find the slope of the secant line? Well, what we can do is we can start off with, the slope of the tangent line, So the instantaneous rate of change is the slope of the tangent line. And so to find this slope, what we do is we start off with the secant line formula. And what we're saying is, I'm going to try to highlight the 2 order pairs here. What we're saying is, okay, we know how to find the average rate of change between those 2 points. But what we're saying is, let's shrink the distance. Let's shrink the distance between those 2 order pairs. What that means is we're going to let h become smaller and smaller and smaller. And as h shrinks, okay, as h becomes smaller and smaller, this right order pair is going to move to here. It's going to move to here. It's going to move to here. And each time, we're going to have these points getting closer and closer to that leftmost point until it gets infinitesimally close, right? And then when we're super, super close, almost exactly on top of that original order pair here, then we can take the slope of the secant line. So to put that all together, how do we make h become really, really small? Well, that's why we spent previous videos talking about limits. So putting this all together, here we go. The instantaneous rate of change is instant rate of change is the following. Here is the formula. It is the difference quotient, okay, or the average rate of change. So f of x plus h minus f of x over h. But as I said, we want to shrink that h, that distance h. So what we do is we take the limit as h approaches 0. Okay? So there we go, folks. So that is how you calculate your instantaneous rate of change. You take the limit of your average rate of change. You take a limit of f of x plus h minus f of x over h. Okay? And when you do it for a specific x value, that'll tell you precisely the numerical slope of that light blue line. But in general, there's this concept called a derivative. And what a derivative can do is a derivative is basically a formula that can help you calculate the slope of that tangent line no matter where you are on this graph. Let's say I wanted to calculate the slope of the tangent line right here. Okay? Well, all I have to do is just repeat that process and plug in that particular x value. And this is what the concept of a derivative is. Okay? So a derivative is a formula for the value of the instantaneous rate of change. Okay? So basically what I'm saying here is if I know f of x, then I can come up with this concept of a derivative. Okay? And so now I want to introduce some brand new notation for you guys, and this is notation we'll be seeing for the rest of the semester. So how do we denote that we're taking the derivative of a function f of x? We're going to use this notation. It's f with it looks like an apostrophe up there, of x. And this is read as f prime of x. That's how you read that. Okay? And this means you are calculating the derivative of f of x. Okay? All right. So in the homework, when they ask you to find f prime of x, they're saying, hey, find the derivative of your function f of x. And how do we actually do it through that process? We take the limit as h goes to 0 of, so actually let's write that down. So here's the formula for f prime of x. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? All right. Let's get into a few examples here. Make sure you guys got this down packed. Let's see here. All right, here we go. So for example, suppose f of x is x squared minus 6x. We want to find f prime of x. We want to find the derivative of f of x. Okay? So let's keep in mind here, f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay? All right. So just to so let's just go ahead and jump straight into it. So what is the derivative? So f prime of x equals, okay, right now I'm focusing on, well, let me write my limit. It's the limit as h goes to 0 of f of x plus h. Okay, so you guys remember from our function notation, if I asked you, just really quick, if I asked you to find, let's say, f of 1, what does that mean? That means everywhere I go to f of x, everywhere I see x, I replace it with the 1, right? So that would be a 1 squared minus 6 times 1 if I'm still using the same f of x, right? F of 0, same type of deal. So keeping that same energy, f of x plus h is in the same vein. Okay, f of x plus h means you go to f of x, and everywhere I see an x, everywhere I see an x, I'm going to replace it with what's in my parentheses. It's f of x plus h. So what does that look like? Instead of x squared, it's going to be x plus h quantity squared. Minus, not 6x, but minus 6 times the quantity x plus h. Okay? So all we did there was just a substitution. So all of this that I'm highlighting is f of x plus h. Okay? But we still have another part of the formula, right? We still need to subtract away f of x. Okay, we still need to subtract away f of x. So then what we're going to do here is minus, very important, parentheses, our original f of x, which is x squared minus 6x. Okay? So that is, let me get my color coordination correct. That is that part of our derivative formula. And then we put this all over h. Okay? All right, now I'll say this. Depending on which homework platform that you're using, this may be the correct answer. You may want to stop here. But what I'm going to do is I'm actually going to work this all the way through. But please note that you may, in your homework, this may be the correct answer. You may just stop here. But let me work this all the way through. Okay, so now what I'm going to do is I'm going to FOIL out the x plus h squared. Okay? So really quickly, if you come up to the top here, let me do it in a different color. If I have x plus h squared, which is x plus h times x plus h, you're just going to FOIL it out, right? X times x squared, x times h is an xh. Now I distribute my h. H times x is also an xh. And then h times h is an h squared. So putting that together, I get x squared plus 2 of those xh's plus h squared, okay? All right, so x plus h quantity squared, for the reasons we just went over, is x squared plus 2xh, okay, plus h squared. And now I'm going to distribute my negative 6, so I get a negative 6x minus 6h. And then I'm going to distribute my negative in the magenta, which gives me a negative x squared plus 6x. Be careful there. It's all over h. Okay. All right. And so now what I want to do is I want to look up in my numerator. I want to combine any like terms. So I see I have a positive x squared and negative x squared. They're going to sum to 0. I have a negative 6x, a positive 6x. They're also going to sum to 0. So they're going to knock each other out. And so we're left with the limit as h approaches 0 of 2xh plus h squared minus 6h. And this is all over h. Okay? Then the next thing I want to do, so I notice right now, if I stop right here, remember our limit lecture. If I stop right now and try to plug in 0 for h, which that's what we do with the limit, right? We're trying to plug in that 0 for h. I'm going to get 0 over 0, which we know is indeterminate. So what do? If you remember what we did before in previous lectures is we try to factor the numerator. Well, yeah. If I look at my numerator here, there's an h in common everywhere in the numerator. Let's factor out that h and see what happens. So we have the limit h approaches 0. I'm factoring out an h, which leaves me with 2x plus h minus 6 all over h. Okay? And because my h in the numerator is a factor, meaning it's multiplying, it's not just adding and subtracting, but it's multiplying, I can cancel out that with the h in the denominator, and we're left with the limit as h approaches 0, goodness gracious, of 2x plus h minus 6. And finally, I can plug in, now I can just plug in 0 for h, right? So if you remember our previous lectures on limits, we can now just plug in 0 for h. Not for x, but for h. In doing so, we get that, well, the derivative f prime of x equals 2x minus 6. Okay? So what does that mean? That means that if my graph is a parabola, which it is, that means that if I want to calculate that the slope of that light blue line there, the tangent line, all I have to do is plug in my x value into 2x minus 6, and it will give me the appropriate slope of the tangent line at that x coordinate. Okay? And so that's what a derivative is doing. But as I said, I want to stress this. In your homework, just make sure you look at their answers that they're looking for. As I said, this may be the correct answer that they want. Maybe they don't work it all the way out as we did. But I did want to show you the completed answer, what it looks like. Okay, one more example here. Actually, let me just make one up here. For example, suppose f of x is, I don't know, let's say it's 3x squared plus 2x minus 4. Let's say we want to find f prime of 4. Okay, let's say we want to find f prime of 4. All right, so as always, we start with the definition of a derivative. So we're looking at the limit as h approaches 0 of f of x plus h minus f of x all over h. And this is the derivative. Okay, so we do exactly what we did before. All right, that's the limit as h approaches 0. My f of x plus h will be 3 times x plus h quantity squared plus 2 times x plus h minus 4. Okay, so keep in mind that is, okay, this portion of our derivative definition. All right, minus, in parentheses, the original f of x, which is 3x squared plus 2x minus 4. Okay, and we put this all over h. All right, so this is f prime of x. Okay. Next, what I'm going to do here, and there's multiple ways you can go about this, but I know in particular for this question, your homework, they're not going to simplify it all the way down. So instead, what you do is at this point, you say, okay, if I want to find f prime of 4, that just means everywhere I see an x, plug in 4. So it's the limit as h goes to 0 of 3 times 4 plus h squared plus 2 times 4 plus h minus 4 minus the quantity of 3 times 4 squared plus 2 times 4 minus 4. Okay? All over h. So all I did in this step was I went ahead and I plugged in 4 for my x coordinate, for my x value. Okay. Once again, your homework is pretty particular. That's why I think these videos are helpful. So it turns out that your homework, they do not expand or FOIL out this 4 plus h squared. So they're gonna leave that alone. But what they're going to do is they're going to distribute that 2. So 2 times 4 gives us 8. So we have 8 plus 2h minus 4. And then minus, what I'm going to do here is I'm going to work out my parentheses. So 4 squared, we square first. So 4 squared is 16. 16 times 3 is 48. Plus 2 times 4 is 8 minus 4. This is all over h. And then let's see what we can do to clean this up. 3 times 4 plus h quantity squared plus 8 plus 2h minus 4 minus, let's see, 48 plus 8 is 56. 56 minus 4 is 52. So the parentheses works out to give us 52. And then the last step is to combine any like terms. So 4 plus h squared plus, I'm going to grab that 2h. And then what I'm going to do is I'm going to take 8 minus 4, which is 4. 4 minus 52 is a negative 48. So minus 48 all over h. And we're going to leave that answer just like this right here. There we go. Okay. All right. I really hope that gets you through your homework, and I'll see you guys in the next video.